Welcome back, guys. It's been a while. I hope everyone is doing well. Yeah, this is where we left off last week. Mm, we were going through the DTB table to pass the available physical RAM, and we were able to pass it. I was just walking as we expected. And where's it? I guess I'll just. If I could move it a little bit to the side. I guess it's good. Okay. Okay. Fine. Okay, this is where we left off as last week. This is exactly where we left off. And we can also maybe just go through what we did last week. We just created the FTDTB structure and some read operations to switch the bits because of the NDNS, and then we were able to read into the structures based on indexing, and we just only care about memory, so we hard code those things and make sure we jump into the proper token, and we finally just take out the register within the memory and we read those bits and we have the total here and we are good to go, and it returns a U64. Okay, and one more thing that needs to be checked is okay. Now let's get things straight. Well, exactly, why did we even start with parsing DTB? Because we wanted to yeah, let's just read that part. It will make more sense if we do that. I guess it's part 6. Yeah, so we need yeah, we started off the week before that we jumped into the VA. Now that we are inside the VA, we need to think about the helpers that will be used. So because in case we are inside a memory and the kernel processes and user level processes, and they might need new memory, so we might want to give them a helper that can allocate memory, like the one you might have used from the user levels, like the malloc. You just call malloc and you get new memory. And how does that happen? In general, I believe user level programs, every process gets its own heap region, and the heap region is pre-allocated at least for a small amount of memory, and malloc is a user level allocator that works on top of this pre-allocated heap, and it keeps track of everything in the user level so that you don't have to switch between kernel and user. And only when that pre-allocated memory is full, it will try to make a kernel level syscall and increase the overall size. So malloc is a user level memory allocator that is working on top of heap, pre-allocated heap. So but right now we have a we have a VA, no, we have a physical range. So we need to write an allocator that will work on top of this, and this allocator will be called by kernel. So kernel will use this allocator to make sure we use the physical range properly without overlapping between multiple processes, and that's our aim, and that's exactly what we wanted to do. And that's why we started off writing something, and we wanted to know the total memory, and that's why I ended up passing DTB. And like I could have just given that value in a static way, but I don't know why I chose to pass it. But yeah, that's what I did, and I've passed it. Now I have the value. Now, now let's think. Now we have the total memory. Now let's go back. I don't know where that is. Okay, I guess we need to start off in a fresh way. Okay, that's not bad. Okay. Okay, what do I exactly want first of all? I need to write an allocator. What exactly is an allocator? Allocator is just going to make sure that it keeps track of the regions that are currently used, and it's also going to find a new space that's not allocated, and it's going to give it back to the user. So this kind of allocators, so we need to keep track of it in a metadata, and that metadata will be the it will be the bitmap. I just remembered it. It will be the bitmap. So so we have this let's say, where is it? Yeah, so we have this total range of 4 GB. Yeah, so we give it as a 4 GB RAM. If it's 4 GB RAM, then we have like physical space that is of 4 GB addresses. Now we need to keep track of them in terms of pages. So, and we are gonna use pages of 4 KB size. So it would be like 4 KB, 4 GB divided by 4 KB. I said divide, you fucking piece of divide. I think it's just one. Yeah, it's around. I don't know, like so I guess it should be like we have we have like 4 GB of virtual memory. We have 4 GB of physical memory, and we want to divide it into 4 KB pages. So how many pages can make up this 4 GB? So yeah, we just give 4 GB in KB. What the fuck? Gigabyte. Okay. So I was fucking wrong. Okay. So it's like 40 something. I guess if we divide it by 4, we should get this, and if we convert this byte to MB. So we have 1 GB of metadata. Oh, that's not good. No, I'm missing something. Wait, let's just ask this fucking thing. I have 4 GB of physical RAM and 4 KB page size. I need to keep track of this in a bitmap. Think about the design. Okay, let's see. Let's see. Ah, fuck me. I should have divided it with 4096. Probably that's what I fucking fucked it. Yeah, I should have given it as. Because what I did wrong is that this is in bytes, but I did not divide it properly with. So if we go back here, this is in bytes, but then I divided it with 4 KB. 4 KB is like 4096 bytes. Then we would have gotten this, and if we convert this into bytes to MB, then we would have got just it's just 0.9, so it's like 1 megabit. So with just 1 megabits, we can keep track of 4 GB space. So it's like so let's say 1 bytes into hash map. No, not hash map, just bitmap. Not this, not this. Yeah, this is exactly what I wanted to do. We can have it as a static bitmap because we know that 4 GB of RAM can be monitored with a static size. That is, the final bitmap size is 129 KB. Why it's divided by 8? First of all, we have this is the, that's just this divided by, okay, we know this value, that's just the divided value. Why did we divide it with 8? I want 1 bit per page. Bits into bytes. Okay. No, I didn't understand. I didn't fucking understand. Why did you? Why just? Oh, fuck me. Why did you have to divide it by 8? We have the initial hard just on 4 KB that I understood. About 8. Yeah, that's true because 8-bit is like from my mind, what I wanted to do is like, let's say 0000, let's just write it down here. Where do we, let's just write it down here. Let's say 0000. That's four zeros and five and three zeros. Let's just keep it as a 64-bit. Nah, it's fine. Let's just keep it. 000 will point to the first page, and 00001 will point to the second page, and 00010 will point to the third page. This is what I wanted to do, so that we have a total page of what fucking we have like we have this many pages. I want it like this. I want to design it like this is what. Yeah, I don't want bitmap. I need binary indexing. Yes. Okay, so 8 bits are not enough. I need 20 bits. So I'll be storing it in 2.5 MB. This is way larger than 280K bitmap. Why is it? Mm, I think this is good. We can have 21 bits, and the 21st bit is will be set as whether or not the actual values used. Yeah, it should be good. I don't think. I think it should be good. There shouldn't be any issues. Yeah, but if we use that bitmap structure, I think it reduces down from 2.5 MB to just 128 KB. That's like really good. But how come do you just use what will be the difference between the bitmap I mentioned versus your design? How did the improvements come into play? So in my design, we just for every index, we are just going to set one page. Fuck me, no useful information, you piece of shit. I'll just add an extra bit and put whether I'll just add it like this. I'll add a index in front of it, saying it is 0, and if it's used, I'll just set it 1. Well, how is it is not useful? I just want to know whether this page is used or not. I'll just set it to 1, and I know that it's used. You fucking mon. 1 bit per page. Free I used. Okay. What does that mean? But how? Explain the design, you piece of fucking shit. You are just going to set it like the first bit. If it's set, then it's the first page. Then how will you know the 108th bit? So in your design, you're just gonna use bits. So what if you want to access the 117th bit? Which byte index contains the bit? So that's why we are. Ah, fuck me. Okay, and understood it. You just divide it by 8, so you'll get the actual index. And within the index, you can just use shift operation. Oh, fuck. Yeah, you'll get the. This, you can just use that as the shift operation. Fuck me. Shit, show. So in their design, what they do is just, let's say we want to access the third page. Then they would have set the third bit. Let's say we want to access this 117th. Then maybe it's in some random number. But to get that number, we know that every number is going to be 8 bits. Because we are gonna store it in that way. So we can take the input and divide it by 8. So we'll get the difference, that is the mod value. Difference being the value, I don't know how you mean it. I guess that's the mod value. You'll get the difference. And you can use that difference to shift the bits. So I guess if we divide it by 8, it will be 337. So that's 32 plus 37 is 5. So 5 is the difference. It's just doing like this, 32 minus 5. So 5 is the difference. So we can go to the 30. We can go to which byte will divide it by 32. Now what will be the index value? Index value will be 14. How? Yes, if you divide it by it will be 1, and 4 8s are 32, so it's 14 and difference is 5. Numerator is, see, it's the I just don't know how to refer the division. So it's the value is 14 and the difference is 5. So the index will be 14, and shift operation will be 5th bit, because we have to left shift or right shift. You have to left shift. No, it will be from the left to right. So you want the 5th bit, so you have to right shift. Yeah, you have to do right shift. No. What? What they have done is, we know that in this we want to write the fifth bit. So we take 1, we shift it left the first bit to 5. So it's like this. Let's say the 14th bit has 0 0 0 0 4, and so fifth bit is 1 and 1 2 3 4. So the fifth bit is 1. This is the input, and we have 1. 1 will be like 0 0 0 0 0 1. Now we have to shift this left by 5. That would just give 0 0 0 1 0 0 0 0. Now if we AND those two values, we'll get 1. So we'll know that it's 1. But what I was thinking is that we can just left shift this by 5 and it by 1, I guess. Yeah, and it by 1, because the first bit will be 0x1, and we'll know whether it is true or false. Yep. No, will it work? And is 1 and 1 is 1. Everything else is 0. Yeah. So will 1 just means 1 2 3 4 1 2 3. So no matter what else is there, it will be zeroed, and only if the first bit is set, and we have 1 already here, so we'll get 1. I guess it should work. Yeah, it should work. Yep. Now we got the idea of what exactly we are supposed to do. Okay. So we need to create a bitmap. We know the total size that we have taken from the what is that? Where do we take it from? Okay, one more thing. Where do we store this bitmap? Usually, where do kernels store this? I mean, it's just going to be in the physical RAM. So we just take a page within the kernel and we set it to true and we put it there. That's it. And we know that it's always going to be set to true, so nobody else can use it. I think that should work. Yes, it should work. Let's try. Then I don't think we need anything else. We could just create it ourselves. We have all the information. We get the total RAM and it will be stored in x0, so we could now we need to create the map, store it. Maybe instead of keeping it as total get RAM, let's put init bitmap. Also, whichever place we decide, we also have to create a create a page translation entry for that. What else do we have to do? Let's think about it. Can we do this after we get into the kernel? Is that possible? After we get into the kernel, we won't be able to write to physical address. I mean, we can write to physical address. Yes, because I still haven't removed my identity map. I'm jumping into kernel entry, but I still haven't removed the identity. So the identity map is still there. So I believe we can move it. We can jump to kernel main and we can write it in the kernel main itself. I think it should be good. Should be good. Should be good. Let's see, what do we want to write? We want to call bitmap. Okay, so we go the extend. Should we import it? Import our extend. And we'll use extend. And what it is? It's what did it go back? I think I have to press Control I, no, Control E, no, Control D, no, Control A. Yes, it's Control A. Yeah, I'm just also trying to learn Vim. I usually do know how to use it, but sometimes I fucking forget things. So yeah. So it's just so fucking annoying sometimes. Okay, what else? Okay, now we need to define that init bitmap and call it here. Before that, we also need to, yeah, we can just write everything down in DTD, but that's just parsing logic. I think we should not group them together. Let's just copy that and paste it here. Okay. What the fuck did I just do? Did I not copy it? What the fuck? How many times do I have to do that? Okay, now it's done. Now we can write the extra helper. that is going to do what we want to do. That is void init main, no, init map, init allocation map, allocated map, what do we call it? Allocated, allocation map, allocation map, and it's going to be void. What else? Nothing much. You can keep it as void. Within this, now we can call uint. What is that? 64. What would it be? What the fuck happened? Okay. Uint total physical RAM is get total RAM. Okay, that's good, that's good. Why do I keep it as void and expect it to return something? I don't know. Uint 64. Okay, now it's good. Now we have the total RAM. We need to create the bitmap based on this. How do we do that? Will static char buffer allow that? I don't know. I don't think it will allow that. I think we just have to create a static. I think if we want, I don't think that's possible, because if I say uint32 bitmap equal to, what is it? Total physical RAM divided by 496 04096. Okay. This again divided by 8. This is the size. So let's just put size. Uint 64. And now that we have it, we can create the actual bitmap. That would be bitmap and bitmap size equal to 0. Would it work? I don't fucking know how to initialize um, initialize a fucking char buffer in C. Oh, fuck me. I think you cannot. I don't know. I think you cannot, can't. Oh, I don't think so. I think you can only. What? Incomplete type. Oh, I'll just put starter. It'll be so much easier. Mm-hmm. That's why I'm feeling like maybe if we just allocate this in the as that linker, it'd be so much fucking easy, and we can just use it there, and we can align it by 4 bytes. That's why I was about to ask that. Where do kernels usually store this? Can I keep mention this in the linker directly? Oh, am I fucking stupid? Stupid. Static memory. Okay, I can give a variable. Yeah, I guess I cannot give a variable because there's something like something called static, and some things are not supposed to be dynamically allocated. I don't know, at least something like that. I remember something like that, but I don't fucking know for sure because it's a bit. And if I let's say keep 5, it should work. But if I put bitmap size, it works. It'll work. Okay, then what's the big deal? Yeah, this is what I was thinking. Maybe we could just keep it here and use that. Use that here. That is good. And I want it to be dynamic. Okay, let's just keep it like this. And we are not gonna do anything else, so it should be good. Wait a minute. If I initialize this, it will be initialized in the fucking stack. Ah, shit. Yeah. Either I have to allocate it outside somewhere here, then it will be put inside BSS directly, or I have to use some sort of dynamic memory, because if I do it here now, it's going to be stack. That's not fucking good. What if I move this entire thing out, and if I just paste it here, what would happen then? Yeah, function calls ought be allowed here. I'm so fucking dumb. Yeah, that's not possible. I have to allocate it in some. I need to dynamically fetch the physical total memory and do all calculations and then initialize the bitmap. So which location would be good for that? Calculate the number of pages, allocate the storage dynamically. Where do you put this bitmap? Yep, I think yeah, that's the only way. Oh, they just create a temporary allocator. Oh, interesting. If that's not possible, you just create it in the linker script. That's the second solution. What's the bad thing about it? Harder to relocate. Okay. Once things get going, maybe it will be hard to reallocate things. Camelug. What the fuck, man? I don't have any macaque. It's a chicken or egg problem. Best solution is just to create a simple YALI bump allocator. Oh, it's called bump allocator. It works like free paging. Ha ha ha. Maybe I'll just go with this approach. It seems like too simple. This one needs some extra work. Also, I need this portion. Maybe I can allocate that. I mean, what's the difference between a temporary bump allocator? What is the fucking difference between developing a temporary bump allocator, bump allocator versus directly creating a region in a linker script? Because even in bump allocator we are taking region starting address to do all things, because even in there we need some starting address. So technically that's starting address is written in the linker script. So what's the point? What's the fucking point? What is the fucking point? Oh, give it any physical free range. But how do I know that physical free range? First of all, if I don't specify it in linker script, is it a physically free? Because there won't be any page tables, but it's identity mapped. No, there won't be any identity because I am inside K-main, so there won't be any. Only if I put it somewhere here after the stack, then it would have some. I think I cannot put it after stack. I have to put it before stack because stack has to grow downward, no upwards, and heap grows downwards. Something like that. I don't know. So maybe heap will be in between this. Before that, I can put this. But even even for that, I need to know that region is not used. How will I know that? How would I know that? What? Bootloader will tell me that? How exactly would it do that? Mm, I don't know, man. I'm not convinced. Not fucking convinced. I am not fucking convinced. How would you. How to. Do you write. Mm, mm, allocator. YALI kernel memory allocation dynamic memory allocation. What? You piece of shit. They're trying to check my fucking history. You fucking morons. Yearly kernel time is managed using a specialized allocator called memblock. Okay. During initialization before the standard. Yeah, this is what I wanted to know. Because during boot phase, we don't have the kernel standard memory allocators. Memblock manages physical memory region and views system memory as collection of continuous regions. Yes, yes, exactly. We have regions, lots of regions fucking specified in this linker scripts. Okay, so what do we do now? Okay, collection of cha cha cha. Oh, fuck me. This is what ChatGPT also told me. It's fucking called reserved and physical memory. Mem block, mem type. Subduing via. Okay. Sounds like memblock add notify. Okay, it's just that they also have special YALI memory allocators, and how are they defined? that would help us. Memblock add. Implementation of early memblock add. Boot time memory management. Oh, interesting. Okay, it just copied the same fucking thing. Okay, this was copied by that fucking AI. Okay, got it. But I just want to know, where do they start? How do they know that everything below this address is completely fucking free? Cannot use normal memory management. Call them dark websites. Memory describe the physical memory available in kernel. This may be differ from because the regions that are allocated. Okay, this will give us the information about the regions that are already allocated. I didn't understand any fucking thing. Okay. Okay, it's time to read the fucking code. Unlock internal. Unlock. If we just copy and paste it somewhere, and if we go into that, and if we copy again this and fucking paste this here, is there another it's used within this. I need the definition of this, you piece of shit. Okay, let's hope that this guy has explained everything for us. Oh, here's it. It's memory unlock. And if we go into memory try, it's just getting a pointer and it is setting. If we go into that, we have KZ unlock node. That is not good. I thought there is no standard K allocators. Standard K allocators are not yet being initialized. What the fuck is this? Allocate zero memory from a particular memory node. What is a fucking memory node? Oh man. This is K fucking malloc. Why did I click that? what did I need? It's KZ alloc. Fuck me. I don't want this fucking thing. First look it first looks for a available memory region, then tries to reserve it. Searching for a free block is broken down into multiple helpers by low level helper which returns the base address of the region on success. If everything goes well, serves entry and then it adds a new entry into memblock.reserved. Okay, so it is true. At that point we do have a structure called memblock, and those memblock has all the information about different blocks and what are the things that are currently reserved. And even if we add some new region, we still make sure that we say that it's used you for. Okay. 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 I get that Linux is keeping track of every block. Early boot too, but start with at the absolute bare minimum. Where will it start to look for free memory? Which is it even the right question to ask? Because I want to allocate free memory, but I don't have any high level allocators. I just want a simple static char buffer allocator. So I need new memory. I was thinking maybe I could add it to the linker script by providing it a region. My thinking about the right way. Okay, let's think about the story now. At the absolute beginning, you do not search for free memory. You already know where the free memory is because Bootloader? What the fuck is a bootloader, man? I don't have any boot fucking loaders. I have a QEMU and I have a linker script that I say that the kernel should start here, and everything else is defined by fucking me. I don't have any special bootloaders. I wrote my own start.s and I am using QUMU with now let's think. Now think again. How can I design this? Should I consider a new region or what? You're not using grub. Yeah, that's the fucking thing I'm talking about. I don't have a fucking bootloader. I just loaded my fucking self. I just put the kernel ELF into starting address of 08888, whatever 8 it is. You have no memory map. Literally dropped blindly into at address. This is bear boot, whatever fuck you say. Oh, they use no bootloader scenarios. They use hard-coded memory map. Okay, you use this as a compile time constant. This is what I was talking about. I could have just created a new memory. Yes, you fucking moron. I knew it. How else can you fucking know where to start? Because you need somewhere to start. And that somewhere has to be defined somewhere. And that fucking somewhere is here. Fucking bullshit. Now let's align it. Alignment is the important part. So let's align it. Align it with 4096. And then start allocating. I'll just put a big number here. Oh, I have to make sure it's behind this because my stack top is here, and probably maybe I'll increase the stack top. Okay, then I'll just allocate it a little bit. I need 128 KB, so we are reserving 512 KB. Okay. putting some values to we can block memory start. Block memory end. Okay, this is perfect. I think there should be enough KBs because stack is only starting at 0 in the 5th bit, so there should be enough space. Oh, it should be good. Ting. Oh, why did he put it inside BSS? Should be inside BSS. Inside BSS, is there any such requirement? No. Okay. Okay, then we'll also do the same fucking thing. You can put it here and okay. Unable to write. No. What? No space left. Is it so? Huh. Which is my primary device? I don't know. I have to think. Okay. No. What? This. What is this? Why does this have available 290 fucking GB? No. How do I interpret this? Everything else is used 100%. What the fuck? Shit show. It's a shit show. I'm not even able to create a new fucking thing. Okay. Maybe I can delete. Is there any fucking Chromium? I should not use RF. It's going to be my death day. What the fuck is this? I believe there is some Chromium, so we can delete that. Okay, so that should at least free up 100 GB or at least maybe 60 GB, so that should be good. I don't know, I don't remember this actually. I know I have used it some time ago, but I don't remember exactly. Even fucking delete that, it takes taking ages. To compile this fucking thing in my laptop, it took me like 7 to 8 hours. 8 hours to fucking compile a Chromium. 8 fucking hours. How the fuck am I supposed to do anything if my compile time feedback loop is 8 hours? I don't have that fucking time. So I dropped that entire project later on. Sorry guys, I don't know. This just happened. I didn't even notice this. I need to free up some other space somewhere. Oh, fuck me. Okay, okay. It's already over. Now let's just check. Now we have 129 GB free. Okay, that's fine for now. We'll think about the rest later. Some other time I can maybe work on it and fix the fucking thing. There must be lots of random stuff that's there sitting. I can delete those things. So it will be good. Okay, now it's done. Now maybe we'll just compile it once just to be sure. We'll just move this. If we place it here, what? Pain. We need to locate. We need to write a helper. We need to fucking write a helper. Maybe it's locate memblock. We'll also use this memblock. Put memblock. And size will be bitmap size. It will be a pointer to array. Will be pointer to bitmaps. Okay, that should be good. No, it's array of pointers. It's not a pointer to U8. It's array of fucking pointers. No, what the fuck is an array of pointers? Yes. It's just array of pointers. No, it's array of pointer to U8 int. Pointer to U8 int. And how do we know the size of it? We don't know it. We just make sure we don't go past it. Because we are allocating it here and we know the size. So we make sure we don't fuck it up. Maybe we can write those yeah, memory blocks here. That would be good. But this already looks too big. We'll write a new file. If I write a new file, I have to add them to the script. That's too much work. We'll just stick with the lazy way. Why is there so many fucking commands? Okay, we'll stick here. Okay, what are we gonna write? We want to write. It's gonna. It is just going to give a void pointer. Mm-hmm. And it's mem block, and it's going to take uint64 as size. I could use usize. Oh, it's fine. Void pointer. I recently learned that we could use void pointer. Let's say you have a function and you don't know what's the proper type it's expecting. Let's say it has some sort of inheritance, and you have a type that you know for sure is going to be accepted by the function. Instead of giving the type, if you just put void pointer, it's going to implicitly convert it. It's gonna trigger implicit conversion because it's a void pointer and the function has a type, so it's automatically gonna trigger it and it's gonna convert it. I did not know that before, so yeah. Okay, now we have a mem block. We know something that is extend start and end. Mem block memory start. Extend. What? Using VS Code and Vim together is just pain in my fucking. How do we import this fucking thing? I don't know. How do we import that? How to import that linker script variable into C? You just put char. You just put 8. But they are not. That's up to you to decide what kind of pointer you may want to consider it. Okay, makes sense. We can take this as uint64. 64-bit blocks. Uint. Block memory start. They have done is, if we just cast it to U8, we have the actual address here. This variable is just an address. This variable holds an address, so it's already a pointer. So oh, wait. I'm confused. It's already in pointer, right? This is so this holds the address, so we can take the address of this variable as in a variable in C, not the linker scripts, and take its address and say that this address is pointing to a U8 star. And this address is an U8 star. Yeah, that's correct. Because let's say this is 0x10 and this bitmap start itself is a variable, so that will be, let's say it's in some stack. So we take the stack address and say that that stack address is pointing to U8 star. No, it's pointing to U8, but this variable is pointing to U8. This is fucking annoying. Whatever. No. Now what do we do? We know we have a size. We need to confirm that it's not beyond that size, because we know that our total size is only 512 KB. No. This is total size. We just want to allocate this space there. So then in that case, it wouldn't be a general allocator. We are simply allocating this for the sake of initializing this single static memory. That's all it's going to do. It's not going to be used as anything else. Okay. Let's think in that way then. What do we do? Now we can write it like block. Mm, it's already pointed to that arrays, and we have already allocated it. There's nothing here to point to. We could technically just say mem block and take the size and just say return u block this is 512 KB. Let's say we only want to take 112 out of it. That just means we should not read past 112. Nothing much. Yeah, exactly. We really don't have to do anything other than that. Maybe we could just say if the size is greater than 512, return null. Because we don't have that much space. Else we just return block memory start. Nothing much. There's no null. I'll return 0. Okay. There's nothing much to do. It's that simple. And we can put extend void star mem block uint 64 size and we could cast it to uint 8 here or whatever the fuck we want it to be casted. That's it. Now it should work. It should fucking work. I believe it should work. I don't know. I think it will work. And we can return bitmap. Okay. Perfection. I hope so. I hope so. It's perfection. I believe so. Uh, we get the RAM, we do the calculation, we send it to memblock, and we return it. What memblock does not do anything. We have already initialized the regions there, and we know the start, and we know that end is in 115 size. So as long as the size is within that, we can just return the memory as void star. And this should only be called once, because if you call it twice, we are going to return the start again, and that's gonna be memory corruption. Fucking corruption. Just to be sure, we also have to confirm one more thing. That is, where is it? Where is it? Hmm. If bitmap equal to 0, then we put ur printf allocation failed %d for bitmap size. Okay, hopefully everything is correct. Now we can call that thing here. Uint 8 star bitmap equal to init allocation map. Okay, let's compile it. Let's see how many errors we get. Why do I put cargo? Yeah, I was recently fucking writing this fucking thing, and it's completely unsafe rusts. It was so much fun. Rust developers would kill themselves if they see star, and everywhere I'm getting don't use fucking unsafe, but I have just used unsafe everywhere, in every possible place. Yeah, that's why I'm typing cargo here, but it's not cargo. We have our own build script that would be bash builds, and it compiles. Let's see info regions. How to how to see all regions in GDB. The fuck? Info files. Okay, we do have it inside BSS. Okay, that's fine. Yeah, we placed everything inside BSS. We go here. Why do I know? Okay, I didn't save it. Maybe that's why it compiled. I don't know. Okay, it's still compiled. Happy. I didn't save the linker script either. Oh my fucking god. Then how did it compile? I don't know. Okay, let's just check if we have this. That's it. X. And we can cast it as void star. Why does it? Okay, maybe it's before, because I'm casting it, it's showing the variable inside it. How do we print this fucking thing? Fucking. Okay, we'll just disassemble memblock. And memblock is supposed to be nothing but a if condition and a return. Probably 0x22 means 512. I don't know. I recently figured out how to. Oh, fuck me. Yes, it's 512. So, what else is there? After that, we are passing some zeros. I guess this is that 8200. This is where our fucking thing is initialized. Yeah, it's possible, more likely. But I hope 8020 is not used anywhere. I think I used it inside MMU. Maybe we'll have to change that to fuck. Yeah, I think I used it here. Yep. I think I can move this. Okay, I'll just add another. After this, let's add 0x 1000. No, 5000. Okay, now if we try it, and if we disassemble memblock, yeah, we are around 7000, and I believe we didn't use that. Ah, fuck me, we have used till 8000. And it's 4 KB. Why did I use it's 4 KB? Then it's just 1 and 2 and 3. Why do I need this? Maybe I'll just change it. And it's 2 and this is 3. That should be enough. And everything else is dynamically generated, right? Yeah, I think so. Everything is dynamically generated, so I don't have to change anything else. It should work. Oh, fuck me. I changed one thing and it Fucked up the entire thing. Uh, why did it fuck up? I just changed 3 things. It is in the same thing, and it's a 4 KB page. Maybe it's aligned. Okay, it should be aligned in 4. I think I'll use this then. 2, 4, and 6. I think this should work. I guess there is some alignment requirements too. Yep, now it worked. Now our main thing didn't work, so but still at least this worked, so we should be happy. And we can put 7 here. Disassemble MMU. Not that. Disassemble mem block. And it started at 9,000. I think 9,000 is fine. I hope there's no alignment issues. It is stuck, so let's check one more thing, that is QUMU. Okay, it does not have that. Tail -5. There's nothing there. What the fuck? What the fuck is in there, first of all? There is a lot of fucking things. This is why I used tail. Maybe I used it wrong. -N? I don't fucking know. Tail. It's /n. Oh, okay. I got it. You just put 5. This should work. Maybe the file is too big, that's why it's still processing. Maybe that's the case. Let's just remove QUMU. Remove it. Run our scripts. Continue it. Kill it. Now quit it. Now if we run tail 5, still, at least it came a little bit faster. We can put 15 or 20, maybe 40. Okay, what's the fucking exception written? So we got an exception, and what's the exception? Data about. I don't understand anything. Let's just copy fucking. Fuck me. What's this here? Translation faults. Oh. This address was accessed and we got a translation fault. Why did you access this fucking address? First of all, who the hell, who the fuck asked you to access that? Who the fuck asked you to access that? Why? We are trying to get the total RAM. Well, let's see if first of all, let's see if this total RAM worked or not. Maybe something is wrong in the get total RAM. Let's see. UART printf. I think it worked because last time we tried it. No, it did not work. That's the issue. We didn't even go into this block. We have something wrong here. Okay, let's see. Okay. I have DTB base 4000 and I don't have page table entries for that. You fucking. Okay. Let me write that. That's a lot of fucking work. Shit. That's why maybe I should just get this value even before and I pass it down to K-main. How does that sound? Because if I have to jump into kernel main and then parse it, then I need page table entries for this fucking address. What do I do? Think about it, guys. Think. What the fuck do I do? It's been already almost 2 hours. Let's just get this one part working and then we can take it to the next session. At least we need something to be done in this session, so yeah, let's just add those entries, or we can pass it down from there. I don't know. What do I do? I'll just add the entry because if I have to add that entry, it should be a level 1 entry because 80 starts at level 2, I guess. No, I mean index 2. Here it will be index 2. Well, maybe it's just better if we call the function here, save the output, use it, pass it down to kmain and use it. Or we'll use some cheap trick. We'll save it somewhere in 8,000. Yeah. And we don't have to do anything else. But that won't be scalable. My idea is that I know I have page table entries for 8,000, so I just write that output to 8,000 and I can read it here. It's so fucking stupid, but it will work. I think better solution would be just to get do we have it still here? Yeah, we have it. So let's just call it here bl and we'll move it to we'll write it to how to write to an address. I need to write to address 0x 8000. If I write to this, it will be I can write to this address. I know for sure that this address is not used anywhere. Value from register x0. Okay. As simple as that. We put what do we put? We'll put ldr x1 equal to 0x 80A01234 and we put store x0 from x1. See, x0 into x1. Now this particular variable value has the entry, so now all we have to do is read it from there. And we have to do it as soon as possible so that we won't have to deal with any bigger issues. Total physical RAM. Oh, if I could fucking type. Ah, fuck me, bro. Fuck me. I'm back to square one. Okay. Now I could just uint 64 equal to uint no 64 pointer. Val equal to 0x 088 01234. This address, I'm holding an address and that address has uint64. And I could just put star val. Oh, if I fucking did everything correctly, it should work. I don't know, let's see. We have so many fucking errors. What the fuck is this? Yeah, how you have to cast it? No, 64 pointer. Is that what you want? Okay, I guess that error is gone. Now we have a new error saying God uint 64. What the fucking let's see. Okay, at least it compiled, but nothing happened. So what's the error? Now we have an error at this address. Why? We have page tables for that. Oh, it's 6. That's level 3. But didn't we map everything? Okay, at least things are happening. Yeah, okay, let's just write in another index. Block descriptor, not table descriptor. So virtual memory is 0x 80A01234. If our helpers are correct, it should work. Yes, but what the fuck? Total RAM is 0? What? What? What the fuck? Total fucking RAM is 0. Maybe I have to put LD. I don't have LD descriptor. This is my own fucking U print. So I only have D. Okay, let's just see it in our actual visualizations to see if it actually works or not. Let's put B star B bracket mem block, and we can continue. Okay, so mem block does not work. No, it has worked, because if it doesn't work, how come I am here? Oh, I want to take this. What? What? Is it that it's because MMU? Or should I use star? Or is it fucking fucked up? What the fuck is happening? It is going there, but it doesn't stop. Oh my fucking god. Where do we stop? We can stop right before print, because print is going to take that value. Okay, that makes sense. We can put break uart printf. Now if I put, nothing stops. Something is wrong with my fucking GDB. Okay, fuck me. Let's just put kmain. At least that will stop. Hopefully even that doesn't stop. Maybe something with the MMU. It doesn't stop at all. I just remembered the ultimate trick I just learned recently. What is the instruction in C that will trigger instruction in ARM? Trigger debug breakpoints. So we can just add that and it should trigger it. Write the CASM for that instruction. Inlined C. Yep, this is it. Now we can add this. This here. I don't know if a normal function can have ASM. Will it say anything? No, it won't say anything. Yeah, it stopped. Did it stop or what happens? It stopped, but I don't see anything. I don't think that is going to work for us. I thought this trick is gonna help us, but it did not help us, but it did stop. But I don't know why it completely, it did not. Oh, fuck me. Now how can I print this properly? Or maybe I'm fucking doing something wrong. This is an address. This address has a uint value. Yes, and this address is stored here, and how come, how the fuck, how don't understand. I don't fucking understand. Holy fucking moly. We have to go the hard way, that is to just put SI and hold enter. Let's see. Once read RAM is done, is there a way to get out of function? I know there is, but I don't have the patience to do so. So I'm gonna just hold and hope that function will finish. Or is it in some infinite loop? Seems like it's just doing the same fucking thing again and again, again. Oh god. What the fuck? I think this is not going to help me in any way. Let's put a disassemble. How do we get out of the current function? GDB. You put finish. Let's see. Okay. Now we write that address and we can put x0. X0 has 1000, so the value is correct. So we are executing it correctly. Let's check it once more. 0x A0 A0 1 2 3 4. No, it just has 0. What the fuck did you do? It does not have the value we just took, that is x0. X0 has 1000, but if I store x0 into x1, maybe let's check. Maybe fuck me. Yeah, it's in swapped condition. Okay. I got it. I fucking got it. Now we have to swap it. Swap it. If it's going to take I think 80 plus 0x2 4 6 8 fucking 16 minus 16. What the fucking crap? We have to take this entire thing as 16. So maybe I should say no, I have to first swap the bits. Yeah, we'll do it later. No, I'm fucking fucked. But at least the value is there and our theory should work. It's already written to that address. If we read it here and if we swap the bits, it should fucking work. Yeah. I will do it in the next session, guys. Thank you for watching. I'll be back probably in another 2 hours, most probably. You have to have lunch. Thank you. Have a good day. Bye.